there were three types of projectile motion. What were the three types?
Free fall.
No, that's not a projectile. Free fall is linear motion. A football kick. What do we like about football kicks? Perfectly symmetrical. So therefore, if this takes 10 seconds, the peak is at 5 seconds. Okay? We like football kicks, or golf balls, or soccer balls. Right? Well, a marble off the tabletop looked a lot like the test we just took, yes? Where all the initial velocity is in one direction, and in the other direction, the initial velocity is zero. Agreed? And then the third type, and this is the type that's more complicated, and I left off the other two videos, is when we have an elevated platform, 2 meters.
And you have to divide up the velocity.
And we're doing this. Remember this? Make sense? So let's go through this. Let's say this is, what does he always choose for an angle? 30 degrees at 40 meters per second. Is this symmetrical, by the way?
No.
No. So if this takes 20 seconds, we can't say this is, what did I say, 20? If this is 20 seconds, we can't say this is 10.
No.
Agreed?
Yeah.
We can say that if this is 20, this is 10, yes? But the rest of it makes it unsymmetrical. Agreed?
Yes.
Okay, so projectile, linear, SHM, or UCM? Projectile, because it's moving X and Y. Agreed?
Yep.
So we need a, what's our tool for projectiles? XY table. This is our point of origin, therefore that 2 meters better be recorded as -2 in the Y direction. So let's set up a XY table. And a lot of this should look familiar to the test we just took, by the way. Without even, VF, believe me, there's a lot of editing on this. VF, VI, DAT. Without even looking at it, we're at Earth sea level, therefore, acceleration in the Y is negative 9.8. Acceleration in the X is 0. Because there's no forces pulling it right or left, X or X positive or X negative. It's all straight down. Just like that previous test, the only force was 2 letters. EQ. EQ. All right, what else can we say here? Now we have to look at the picture. What else can we say?
D in the Y is negative.
D in the Y is -2. What's another word for dx, by the way? Range, and we don't know what that is. We got to calculate that. Agreed? But now physics hates. We got to break this into a Y component and an X component. The sine of 30 is 0.5. Therefore, the Y component's got to be 20. The cosine of 30 is 0.86, let's say 0.8. Therefore, the X component is 0.8 times 40, 32?
Yeah.
Are we good? Let's say 32. So instead of, we can't use 40 meters per second anywhere on this table, we got to use 20 in the Y and 32 in the X, and they're both negative? They're both positive, because Y is going up and X is going to the right. So VI in the X is 32, VI in the Y is 20. No acceleration in the X, therefore 32. Can I say this is -20?
No.
Where is it -20, by the way?
Right?
Where
That's
it's level
symmetrical.
with the roof again.
Where it's symmetrical. Right here, the Y would be -20. But the X at all points of the trip is 32, unchanging because there's no acceleration in the X. So once we get 3 things, then we can treat those rows as what type of motion? Linear, projectile? Once we get 3 things in a row, we can treat that one row as linear motion, yes?
Yep.
So now we got 3 things in the Y row. This isn't going to help us because it's just going to tell us VF equals VI, and we already know that. So we got these 3 things. What can I use to solve for final velocity? VF squared equals VI squared plus 2AD. And that, we would get a square root of a positive number. Square root of a negative number is undefined, but a square root of a positive number can give us what or what? Positive or negative. What are we going to choose? Negative, because right here it's digging south. Agreed? How would I find time without final velocity? If I got VI, D, and A? Yes, d equals, I was just thinking, d equals VIT plus 1 half AT squared. But in that case, you'd have to use a quadratic formula. So it might be better to find the final velocity. VF squared equals VI squared plus 2AD. Can someone do that? Does someone have a calculator, please?
904.
Square root of it?
Sorry.
Negative 30? Let's say it's negative 30. Thank you, Hannah. Now we can easily find time using simple VF equals VI plus AT. Negative 30 is the final velocity. What's the initial velocity? 20 plus negative 9.8 T. Subtract 20 from both sides. 50 divided by 10, about 5 seconds. We're okay? What do we like about time?
It's positive.
It's positive?
It's a scalar.
It's a scalar, Nick. Therefore, it could go in both boxes. Now we can find the range. Now we can find out how far away. What equation would we use to find the range?
D equals VIT.
The d equals VIT plus 1 half AT squared. The acceleration in the x is 0. Therefore, it's just d equals VIT. 5 times 32. Hannah, 150, 160?
160.
160 meters. Make sense? So that ball lands 160 meters away. How would I find this peak right here, by the way? How would I find the peak?
Velocity in the y is 0.
The final velocity in the y is 0. Therefore, we really only need y information to find this peak. Final velocity is 0. What else do we know about the y direction?
Acceleration.
A, Jason, minus 9.8.
VI is
And VI doesn't change. It's still 20. Now we can find the time to the peak using VF equals VI plus AT. 0 equals 20 plus negative 9.8 T. Subtract, I know I'm getting sloppy. Subtract 20 from both sides, divide both sides by 9.8. About 2 seconds. So the peak is at 2 seconds. Now how can we find the displacement to the peak? You got 4 things now. You could use D equals VIT. Does that make sense?
Yeah.
Or you could use VF squared. So D equals
Square
VIT
the initial
1 half AT squared.
plus 2
So that would be initial velocity in the
Try it
y,
with this one. Get the same answer.
20 times 2 plus 1 half minus 9.8, 2 squared, 4. Looks like 40 minus 20. About 20. So 20 meters. Is that 20 meters from here to here or from here to here? It's from here to here. Does that make sense? So it would be 22 meters off the street, 20 meters above the rooftop. Agreed?
Yep.
What's unclear? What's confusing? Anything? Don't sit there and say, I don't understand. Did we got it?
Yes.
All right, good. Excellent. Thank you very much. I appreciate it. Everybody smile. Oh, good looking people. Look at this guy.
May the good Lord be with you down every road you roll. And may sunshine and happiness surround you.